it is my privilege to introduce you to Dr. Nilaj Deshmukh, who will be taking on the topic of journey from conventional to electrical vehicle. Now, to introduce him, Dr. Nilaj Deshmukh has done his B from Amravati University in mechanical engineering. He has done his MTech from VJTI Matunga and has completed his PhD from IIT Bombay. Uh, Deshmukh sir is presently the head of Mechanical Engineering Department of Father C. Rodrigues Institute of Technology, Vashi, and is the Dean Faculty of FCRIT, Vashi. He is actively involved in various aspects of academic and research for more than 21 years. Deshmukh sir is fellow member of Institution of Engineers, member of National Society of Fluid Mechanics and Fluid Power. He is a member of editorial board and as as a reviewer committee member in various journals. He is a member of Board of Studies, MIT School of Engineering and Technology in Aerospace, Engineering, Aeronautical, Automobile, Mechanical, MIT School of Engineering and Technology. He is felicitated by the Institution of Engineers Belapur local chapter for supporting IEI activities, that is Institution of Engineers activities. He has received various grants for his research projects from Mumbai University, has more than 15 journal papers in reputed publications, more than 30 conference papers, and I would say they are still being added continuously going on. He is the member of editorial board in Journal of Mechanical Engineering and Technology, Journal of Automobile Engineering, International Journal of Advanced Research in Engineering and Technology, Journal of Mechanical and Production Engineering, International Journal of Automobile Engineering Research and Development, and International Journal of Mechanical and Production Engineering Research and Development. He is on board of a member of various on technical committees for conferences. He is member of organizing committee of various conferences and member of review committees of conferences and journals. This was a very brief description of Dr. Nilaj Deshmukh. I would now request Dr. Nilaj Deshmukh to start with the session. Over to you, Nilaj sir. Sir, your mic is muted.
Yeah. Thank you, Dr. Aqleem, for your nice introduction, which is actually the not required. Today, I'm going to take you to the journey from conventional to electric vehicle, and as a part, of this, if you see yesterday's two lectures given by Dr. Vora and Mr. Nibande, Dr. Vora has talked about the electric vehicle, and he has given you brief about what are the challenges, what are the scope of electric vehicle, uh, and you got the idea that though we are saying that conventional engine, which is a internal combustion engine or a fuel based engine, that also have more than 100 years we are using, as well as electric vehicle or electric drive system that also have the more than 100 years of in service. But there are the many challenges associated with both the systems. But if you see, though there are the challenges with the conventional, now we are saying that it should be replaced with the electric powertrain or power drive. But here, due to the some advantage, due to the multiple advantage of conventional engine, the applications, the conventional engine have the wide applications uh, and grab many things in last 100 years. If you compare the electric and the conventional engine. Now, for if we talked about the conventional vehicle and conventional engine, this is, I can say, a layout of conventional vehicle, where I can say this is a engine, and which is, I can say, the heart of the vehicle, and with the engine, there are the different system that we are using to convert the chemical energy and to drive the vehicle. So if we talk about the cooling system, suspension system, exhaust system, then transmission systems, battery system, so there are the multiple system we are using in this conventional vehicle in addition to that engine, right? And if you see this diagram at the side view, side part, that is a conventional engine where where you can see the complete assembly of the engine, where more than thousand I can say the different components are used for converting the chemical energy into the mechanical energy. now Now, if I talk here again, why I'm discussing these things briefly, the conventional engine here for this one, we're trying to have the multiple people in this group, so electrical as well as mechanical, and I can say now there is a interdisciplinary approach. So here, mechanical, electrical, why not EXTC? Because there are electronics. Why? Because there are the multiple areas where if we work together, electrical, mechanical, and electronics, there are the multiple benefits. We can design a system which is more efficient. So briefly, I will go that in case of the conventional engine, that is we are calling as a heat engine, we know that it's a device which transforms the chemical energy of the fuel into the thermal energy and use this energy to produce the mechanical energy. So chemical energy to thermal energy and produces the mechanical energy, and that we termed as a heat engine. And we know that this heat engine involves the two cycles, basically auto cycle and diesel cycle. And we are saying that in a theoretical things, we are saying that these are the operating cycle on which the engine operates. But theoretically, these two cycles are what the closed cycle, where air is a fluid. But when we talked about the practical applications where the engine, which is based on, let's say, I'm talking about the SI engine, spark ignition engine, which is based on auto cycle, obviously it will take air and fuel as a mixture, and every cycle the air and fuel is going to change, and based on the requirement again that quantity is also going to change. So it is again have the certain advantages and certain disadvantages. So similarly, the diesel engine is taking the air inside and converting, compressing that, and then we are injecting the fuel. Now here, if we talk about, I showed here the air fuel, then it is get burned, and then we are getting the thermal energy, and thermal energy that due to that expansion, we are saying that converting into the mechanical work using the reciprocating kind of the mechanism. There are a rotary engine also available in the market. So we'll talk about the reciprocating mechanism. So converting the thermal energy to the mechanical work, we require some sort of the mechanism, whether it may be a reciprocating, it may be a rotary. And again, whatever we are giving, it is obviously it will not produce that much kind of the thermal energy. Why, how, and that we'll discuss in next slides. Now, as I said, there are two things. One is a spark ignition engine, that is we are termed as a SI engine, right? So here, engine in which the combustion process each cycle is started by using the external spark, right? Here during there is an inlet manifold through which pre-mixed air and fuel, which is prepared by the earlier it was prepared by the spark plug, but now that technology is also changed, that is prepared by the carburetor, and now the technology is also changed, and that pre-mixed combustion is entering in through inlet manifold inside the engine, and then that charge air and fuel, it's getting compressed, and the spark plug is producing the spark, and due to which the combustion process started. And in case of the CI engine, during the suction stroke, air is going inside the cylinder, it getting compressed, and at the end of the compression stroke, the fuel injector is injecting the fuel. So here, both this SI and CI both working on 2-stroke and 4-stroke. But now, if you see in the market, the 2-stroke is almost vanish. All majority of the vehicles have the 4-stroke engine, SI as well as the CI. Just we'll have a short video so that you will get the people, those who are electrical background, will have the idea how this engine work. Can you see this video? Can you see the video? Hello? Hello? Professor Aqleem? Hello? Can you see the video? Any participant can reply? Hello? 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 Can you hear me? Hello?
Yes, sir. Yes, sir. Sound is clear.
Earlier?
Yeah,
I was
here
trying
also
to,
it was there.
here, if you see this video, you can see that different parts of the engine.
Neela, sir, just a minute. Huh? I am seeing some messages from participants that we are muted. Yes, during the session, all the attendees will remain muted. During the question answer, when you raise your hand, we will give you permission to unmute yourself, or alternatively, you can put your question in the chat box. Okay, so please bear with this, because during session, by mistake, many faculties or many participants might by mistake keep their mic open and result in disturbance of the session. So please bear with this. Everybody has been kept on mute forcefully during the question answer session, preferable on the messaging on the messaging chat section of the Teams, or if you raise the hand, I will allow you to unmute yourself. Thank you, sir. Please continue.
Can you hear me? Hello? Can
Yes,
you hear
sir,
me?
yes.
Okay. So if you see this engine, this is a 4-stroke SI engine. You can see these different components. This is your crankshaft, where the crank is there, and then you can see the connecting rod, which is reciprocating, and then to the connecting rod, the piston is attached, and at the top, so this is, you can say, the connecting crankshaft, then this is a connecting rod, and this is a piston which is reciprocating. Then on the top there will be a camshaft. This is a camshaft. Camshaft is used to operate the inlet valve and the exhaust valve, and it will take the power from the engine over the timing chain. Chain drive is there, which is giving the power from the engine to the to operate the valve using the camshaft. Now you can see here the cam is operated, cam, and this valve, you can see that during the suction stroke the charge was entrapped, then it got compressed, and now both the valve will be closed, and at the end of the compression stroke, spark plug produces the spark, and due to which the combustion process start. Now if you see the carefully, the volume at the end of the compression is close to the clearance volume, and within that volume the charge is getting compressed charge is there, and spark plug is producing the spark. It's a very tiny spark, and that spark is converted to the flame, and the flame is accumulating, or flame is consuming the charge. Burning process is starting now. So when it is a multi-cylinder engine, now here this is example of the cylinder 4-stroke engine. So here the 4 cylinders are there. So alternatively, all the cycle simultaneously, suction, compression, exhaust, all the strokes, all the processes are independently happening. Now, if you see that this engine generally operate with very high speed. Let's say there are the engine which are driving around 10,000 rpm, 1000 rpm to 10,000 rpm, and within that 10,000 rpm, just imagine in a 360 cycle, and one stroke is for the small time available for the combustion. That time will be, or it is in millisecond. Within that process, within that time, entire combustion need to complete. But if you see the theoretically, it should be instantaneous. At a sudden, it should give the heat input. If you see the Otto cycle, if you see only the vertical line is there, which means that at a constant volume heat addition is taking place. It is instantaneously, immediately we want. But in actual case, there are we are not able to produce the heat all of a sudden. So there is some time is required for the combustion, and due to which there are a certain problem associated with that we'll discuss in a subsequent slides. Now, if you talk about the history of this engine, here first theoretical things was given in the 1862 by Rodrigues, and he described the principles essential for the efficient operation. Only he has given the principle, but actual 4-stroke cycle engine was developed in 1878 by Otto, and in 1891 they built a improved 2-stroke cycle engine. You can see this. These are the just photographs of old engine. This is a 4-stroke cycle engine given by Otto, and this is the 2-stroke cycle engine by Day. And in 1892, Diesel presented the compression ignition engine, and that is a diesel. So the name is given, and this is a view of that diesel engine. Now, if you see the old engine from 1862 to till today, majority of the invention is for improving the efficiency, improving the efficiency of the engine. A major research was there, and as and when any technology, if you see from more than 100 years, the engines is in existence, but there are different applications it started using. Let's take an example, the largest IC engine. Can you imagine the largest IC engine which was built in Finland, which is a 14 cylinder, which is a 14 number of cylinders are there. You can see in this diagram 14 different cylinders are there. You can imagine the weight is 2,300 ton, length is 89 feet, height is 44 feet, and power you can see 108,920, right? So 1,08,000 HP, and RPM is 102, right? Power to weight ratio 0.024 HP plus IB, HP by IB. Here you can see the efficiency is around 51%. Here, though we are saying that there will be engine will be vanish. No, I'm having a different opinion, as these engine are having the wide application, So we need to continuously carry out our research work for the betterment of better performance of these type of the engine. Now, if we talked about the engine, as I said, engine is taking the fuel. So let's say some that m dot kg per second, that much amount of charge is taking inside the engine. So what that multiplied by the calorific value of that fuel. So that I'm getting the thermal energy uh, given by the fuel. So mass of the fuel into the calorific value. That much amount of heat is produced inside the engine by the fuel. But whatever we are giving to the engine, right? And out of that, we are getting only, if you talked about the modern engine, also the brake thermal efficiency is in the range of 25 to 40%. Now, with addition of the fuel technology, few companies claim that brake thermal efficiency improved up to 40%, up to 60%, from 40 to 60 with addition of the few additional system. That we'll see in subsequent slide. But majority of the engine, or for majority of the application, if we talk the brake power or brake thermal efficiency, if I talked about, it is around 25 to 40%. So now question arises, where the other energy is going? So another other energy is going. The major, you can see here the exhaust heat. You can see the tailpipe of your vehicle, whether it is a two-wheeler or a four-wheeler. The tailpipe, through the tailpipe, around 20 to 45% heat is going into the exhaust as a exhaust heat without producing any kind of the work. Then 10 to 35%, 10 to 35% is going for a coolant, lubrication system, and other heat losses. There may be a convection loss, conduction loss through the different component of the engine, as well as it is giving the heat to the coolant and the lubrication system, and that is 10 to 35%. Why that wide range? Because based on the loading, based on the which application we are using, uh, that percentage is there. Then to take the charge, pumping is required, and as well as these are the reciprocating mechanism. So obviously there will be a friction. So friction and the pumping loss is around 2 to 10%. So now whatever energy is there, out of that, actual work or actual output we are getting 25 to 40% only. But now with a recent technology, it is up to 60%. But on the road, it is highly possible to get that much of the thermal efficiency. Now, where I can focus, where, because here, if you talked about the friction and the pumping, it's a 2 to 10%, but that also I can reduce further, but percentage chances of getting reduced is very less. But majority of here, which is the wastage of heat, that I can convert that as a energy recovery part and use for some other application, or try to reduce these kind of the losses. Now, from so many years, researchers are trying to reduce whatever the losses just now I told: friction loss, heat loss, trying to improve the brake thermal efficiency or brake work, combustion irreversibility, then pumping work, exhaust. Now, what is the problem associated with that? Whenever the researcher is trying to reduce the one loss, which is resulting into the increase in the another. They are trying to reduce the one loss, but other is going to increase. For example, researcher tried to reduce the in cylinder heat loss. They tried to reduce the heat loss. They succeed in reducing the heat loss, but at the same time, whatever they reduce, that much increase was they have got in exhaust as a exhaust energy. So there was an increase in exhaust energy rather than the piston work. Piston work improved. That was not improved, but exhaust energy uh, which is going waste, that is increased. Then if we talked about the lean means the where the fuel quantity is less and air quantity is larger. So compared to that we can say a lean mixture or lean combustion. So here lean operation increases the piston work but increases the combustion irreversibility and decrease the exhaust energy. So that's why here there are the many challenges researchers face. They tried the many things, but during their trial and error, they succeed in one thing and getting another as a loss part. Now let's take an example. Here I am just trying to give you the idea from 1960 to till today what kind of the technology enhancement happened to improve the performance of the internal combustion engine or to increase the brake thermal efficiency. Now, here, if we talked about the here the brake thermal efficiency enhancement over the time period, you can see here that slight increase, let's say from 34%, and it went to around 45%, 9 to 10% rise. And then again you can see there is a some drop after 2000, let's say 2005 to 2010. There is a certain drop in the efficiency. Why it is happened, that we'll see. So what are the technologies researchers were tried in in so many years. You can see the people tried with electronic control. What is that one, that we'll see next slide. Then people tried to increase the injection pressure. People tried to increase the injection pressure. Then there were also the during that trial some advantage, some gain, some losses was observed. Then turbo efficiency increases. Then exhaust gas recirculations. So you can see that variable geometry turbocharger (VGT), variable geometry turbocharger. Then people use the uh, diesel particulate filter and ultra low sulfur diesel. So use of these exhaust gas recirculations and variable geometry turbocharger, then diesel particulate filter and ultra low sulfur diesel, you can and then selective, then you can see that their efficiency is gone down little bit. And there are, if you see again, two things. One is soot formation and another is NOx. So from point 0.6 it reduced to 0.01 with this technology. But if you see, there is a decrease in thermal efficiency with the use of this technology. Then here waste heat recovery systems also proposed by a few researcher. There also the added some advantage and some disadvantage. Then if you talked about the NOx also, it is reduced from 10.7 to zero point 0.2. So that is reduced drastically. But if you see with this technology, there was a reduction in the thermal efficiency. If you talked about in terms of brake specific fuel consumption, this is also reduced from 0.39 to 0.25, and engine emission, that is CO2 carbon dioxide, from 562 to 357. So over the period of time, there is a improvement in brake thermal efficiency and drastic reduction in emissions. Why people thought that to reduce the more emission, that we'll discuss in subsequent slides. So I think all of you got the idea over the period of time how the people are tried different technologies, different techniques to increase the thermal efficiency and to reduce the uh, emissions. Now, what are the technological advances leading to shift the engine management? What is that engine management that we'll see? Now, if we talk, I can categorize in three parts. One is what? The component development. Second one is the sensor development and ECU development. Electronic control unit. ECU, electronic control unit. Why it is required? That's why I said now it's this particular area now it will become as an interdisciplinary where mechanical, electrical, and EXTC people will work together so that will enhance the thermal efficiency and reduce the emissions. Now, if we talked about a component development, so we want a robust and fast response turbo machinery. We required a flexible intake and exhaust valve system. The video which I have shown you, you have seen that one. There, cam operated valves are there. Cam operated valve, it will certain take a certain time, and it will be open and close at a whatever as per the design only. It will open and close at a certain particular time. But we want to have a better performance. We want to have a flexible intake and exhaust valve system. Then again, the cylinder volume is fixed and we are compressing with the piston, and we are getting a certain compression ratio. So here again we may adopt a variable compression ratio. Then flexible fast acting fuel injection systems. As I told you earlier, at the end of the compression stroke, injector is going to inject the fuel. So here, based on my requirement, the I want a flexible and fast acting. It should immediately inject, and at a particular time it should inject the fuel. That system I am expecting. Then high pressure direct injection fuel systems, because certain application I require the high pressure injection. What are the advantages? We'll see in next slide. Then advanced ignition technology. Advanced ignition technology. We have said ignition is with the help of the spark in case of the SI engine, and in case of the CI engine, ignition is due to the auto ignition is taking place. Each molecule is getting sufficient oxygen in during its surrounding to its vicinity, and combustion is going to start at the different parts of the combustion chamber. That is auto ignition we are taking. So here we are expecting some sort of the advanced ignition technology. So these are the things which is at the component development side, which may result into advanced component technology allows you for more complete control of the engine and and the combustion process. We have a more control over your entire process. Then obviously, to have a better performance, if I am using the electronic control unit, obviously I will require a sensor development. So for develop where I require high speed pressures and temperature, I need to measure pressure and temperature at different locations of the engine, so that I will get the idea, and based on that I will actuate the certain thing using the electronic control unit. And onboard emissions diagnostics. So onboard emission diagnostic is now the upcoming area where, based on the sensors output, the injector or other unit is act accordingly, and it will produce the diagnostic system. So I need to have a proper sensor development. Then electronic control unit will be what? New and faster architecture, then combustion feedback, ability to solve the complex problem. That are the challenges with the ECU development. So if we talked about the sensor and the ECU, it will be that advances in the sensor and onboard computing allow for a more active control for pushing the boundaries of the high thermal efficiency. Now I have boundaries. For a different operating condition, I can say my engine or engine which is in my vehicle is giving me efficiency around 30% to 50% or 30% to 45%. So if you have properly designed the electronic control unit with a good sensors and feedback system, I can have the control over the combustion, and which lead to the increase in the thermal efficiency. So this is the, I can say, now becoming the interdisciplinary area where all people need to work together so that I can achieve the required things. Now, if I talked about different engines, very small engine to the large engine, and different applications, RC hobby, smaller genset, transportation system, then large genset, marine application, you can see the efficiencies are different. 5%, it's less than 5% to the 55%. The efficiency is varying because application to application, the engine category, engine type is different, and different technologies are used, and which is based on which the efficiencies and emissions are depend. Now, which are the parameter? Which are the parameter limiting the efficiency of the IC engine or internal combustion engine? First one is irreversible losses. I can say the friction as a reciprocating mechanism. There are lots of friction between the piston and the cylinder part, and other components are also there. As I said, in an engine, more than 1,000 components are there, out of which 5 to 7 component are the rotary component. Obviously, there will be a friction, and that is a irreversible loss. Then combustion irreversibility, that also is affecting the your performance of the IC engine. Then, as I said, the thermal energy we are converting into the mechanical work, and for mechanical work we are using the reciprocating type of the arrangement or a rotary type of the arrangement. Now here, work extraction efficiency is also limiting the engine efficiencies. Here the material limits. So here the engine few component is exposed to the very high temperature range. So we have to select the appropriate material, and there are the very limited materials which can be withstand at a high temperature. So I need to use that material. So material limit is also uh, have some limits on the improvement side of the efficiency. Then engine size, smaller the engine, you can say the larger the um heat loss, because surface area to volume ratio is going to be large, and due to which it is decreasing the thermal efficiency. Larger the engine, more will be the or better will be the thermal efficiency. And in previous slide itself, I have told you that the application, based on this application, the efficiency is limited, and obviously the cost, which kind of a technology I am using for my engine. If the engine is a very high end, obviously the cost is going to affect. So these, how I can reduce the cost so that I will get the better efficiency. That is also again the upcoming area where I can work to reduce the cost of the modern engine. Now, this diagram will give you what are the engine development challenges. Now, if we talk, what is my aim? My aim is to maximize the efficiency. My aim is to maximize the efficiency and minimize the emission. Minimize the emission. And I should use in an engine the variety of the fuel. Different kind of the fuel I should use. This is my challenge. This is my I can say the goal. Now, to how I can fulfill this goal, what are the different challenges that we'll see. If we talked about, the conventional, if we talked about the conventional engine, here you can see the SI and CI are the conventional engine, spark ignition engine and the compression ignition engine. Now here, that variable wall timing, variable wall timing type of the engine, turbocharging, down seizing cylinder. So there are different kind of the things are there. Common rail direct injection, turbocharger, variable geometry, variable compression, ejectors, cooled exhaust gas recirculation. So different kind of the engines engines are there which will enhance the efficiency, but here there are certain points which is reducing. So what are the limiting that we'll see. Then if we talked about the conventional fuel, if we talked about the conventional fuel are the petrol and diesel. Petrol, we are saying the gasoline and the gasoline and the diesel. So if you compare the this is a crude petrol we are getting from the these are the petroleum products, and we are getting after the refining that. So nowadays we are getting very clean, very clean type of the diesel, and where which is having the low sulfur which have low sulfur content. Now here, if we have the alternative fuels, instead of using conventional fuel in a diesel or gasoline, I can use a fuel like biodiesel. I can use dimethyl ether. I can use, which is a synthetically produced diesel. I can have a SVO, that is a straight vegetable oil, like a soybean oil. I can use as a fuel, right? So there are a certain fuel I can use in a engine to reduce the emissions, or to check what are the possible fuels for the IC engine. So similarly for the gasoline as a engine, I can use alcohol, I can use ether, I can use dimethyl furan type of the compound for producing the for using in a gasoline engine. Similarly, I can use a compressed natural gas, or I can use a liquefied petroleum gas, or I can use a sign gas. So different type of the fuel I can use, I can test in a petrol engine as well as in diesel engine. So where is the other challenges I can check. So what are the alternative engines? So here, if we talked about LTC, that is a low temperature combustion. So we know that for NOx formation, the higher temperature is responsible. If I have a low temperature combustion at a low temperature, obviously the NOx reduction will be there. uh, so example of this one low temperature combustion is HCCI, that is reactively controlled compression ignition engine. Reactively controlled compression ignition engine. Then partially premixed PPC, that is partially premixed engine. Then this is a HCCI, that is homogeneous charge engine. This is a partially premixed combustion engine. Then this is a RCCI, that is reactively controlled compression ignition engine. And then SACI, we are using the CI, compression ignition engine, but SA, what is SA? That is a spark assisted compression engine. So in conventional engine, as I said earlier, the in petrol engine there will be a spark, and in case of the diesel engine, due to the auto ignition, ignition will be initiated. But in a modern engine, I can say that SACA, that is a spark assisted CI engine. Then similarly, I can use with the conventional fuel at a fuel cell. I can have a hybrid vehicle and electric vehicle. So yesterday's Mr. Nibandes has explained about the hybrid vehicle, where I can use electric as well as a conventional engine both together for driving purpose, or for producing the power, or for giving the power to the wheels. So here, as or pure electric vehicle. So again, different challenges are also associated with this type of the system. So here, variety of the combinations. As a researcher, I can have the different. My goal should be same, but I can have different combinations. I can use a different fuel in different type of the engine, and I can try to reduce the emission and increase the efficiency. So that should be the different challenges. Now here, uh, the here engine development pleasure to pain. Here I have put it purposefully here. This thing here, if you see in 1940, here the first time the air pollution problem was first time recognized as in the Los Angeles basin. And what was the cause? There were the two causes of this one. One is a large population density and the local weather conditions. Now, we said, the in 1890 around the vehicle first engine developed, and then slowly the vehicle started, and people started purchasing and using that on a road. And obviously, when the more vehicle will be there, the more pollutions are coming out of that. So due to which smog and other pollutants pollutants combine with a fog to form the smoke, right? And which was the problem identified, and then people start thinking to reduce the emission. Till that time, nobody worried about the emissions. And now, if you see the number of vehicle before 100 years and as on today, the large variation is you can observe. So if you see that one, the large quantity of the exhaust or pollutant gases coming out of that one engine. So now you might be heard many news during this pandemic situation, when the lockdown was there, and all the people are inside the house and nobody was using whether a two-wheeler or a four-wheeler or a heavy transportation vehicle also were not running on the road, due to which you might be seeing that our sky become very bluish, clear sky you can observe, and many animals must start moving from the forest to the on the road. Why? Because the pollution on the roadside, pollution in the city side reduces drastically, as there were the no vehicle on the road. Now in 1960, the first that hydrocarbon emission and the CO emission limits were decided. So because afterward many different industries started to manufacture the different engines and the different vehicles, and first emission norms was given in 1966. And then here, more fuel efficient engine people have started thinking, and afterward the exhaust gas treatment emission from here vehicle was limited, that is SCCO and NOx. It is reduced it to the 95% in during the 70%, 70 and 80s. In 17 and 80s, majority of the work was given to what? To reduce the emission, and it was they able to success to reduce the 95% of the emissions. Because earlier people have not thought about the emissions and just simply burning and getting the useful work out of that engine. But due to the adverse effect of that engine's exhaust coming out of the engine, on the people as well as the health of the people, and observe on the different effect on the environment, people started thinking to reduce the emissions, and majority of the work was carried out, and 95% reduction was observed in 80s, 1970s and 80s. If you talked about gasoline fuel emissions, what are the sources from where the exhaust emission is coming? So if you talked about the 50 to 60% emission is coming out of the exhaust tailpipe, from which the unburned hydrocarbon, carbon monoxide, and NOx is coming. So these are the three basic parameters in case of the gasoline engine. Then from the fuel tank, some fuel get vaporized due to the ambient conditions, and that loss, evaporative loss, is also there from 5 to 6%. And crankcase blow by loss. So during that reciprocating operation, some crevices loss is there. Some charge may get trapped inside the crevices of the uh, piston rings and in a crankcase, and then that loss is around 20 to 30%. And some maybe the evaporative loss if it is a gasoline engine, and if you are using the carburetor, that 2 to 3%. Now this is the, I can say, the 30 years before the scenario. But now people have worked hard and they tried to reduce this evaporative loss. They tried to reduce the crankcase blow by, and the evaporative loss from the, and carburetor is also eliminated from the modern engine. And people success to reduce these type of the emissions. Now, if we talked about, if you talked about a diesel engine through the sorry, through the diesel engine, the CO, carbon monoxide, unburned hydrocarbon, NOx, and the smoke, particulate matters, that is coming out of the tailpipe. As diesel is a less volatile fuel, I can say that the evaporative losses will be minimum, and we are directly injecting that fuel inside the engine. So major emission is from the tailpipe, and that is the carbon monoxide, unburned hydrocarbons, NOx, and the particulates of matter. So now here, first, that European country, they started thinking to reduce these emissions, and they have implemented the certain norms, and that norms are called as a Euro emissions norm. And firstly, they implemented in the year 1994, and their term is at the Euro 1. And they use these norms for both petrol engine as well as diesel engine. But if you see the percentage of CO emission or NOx emission, the quantity will be different based on the different category of the engine. So I can say that these figures, whatever I have given here, uh, HC plus NOx or particulates matter. So based on the which category, this is for a light commercial vehicle. So engine to engine category, these will be remain. So here, particular category, these figures are fixed. Now, so here Euro 1 to Euro 6. So they have started in 1994, and they reduced drastically that CO. You can see 2.72 to zero point 0.5, right? And NOx, earlier they have not put any kind of the limits for the NOx. From the Euro 3, they started producing the limits on the NOx. So from zero point 0.5 to 0.08, and SC plus NOx also from 0.56 to 0.176. So they reduce drastically. And you can see the more is what, 0.14 to 0.005. So particulate matter. Now, similarly, they did put the drastic limits for reducing the emission from Euro 1 to Euro 6. So all the manufacturers, those who are producing the engine in the particular category, let's say this is a light for a engine for a light commercial vehicle having the weight 1305 kg. So this figure indicating that the NOx should be below this figure. Otherwise, they will not get the permission to develop that kind of the engine, and that can't be used on a road or using in a different kind of the vehicle. So, firstly, the European country started in the year 1994, and they till that today that they are working on a further that Euro 6 and other part. Now, if we talked about the Indian emission norms, so here always as an Indian, we should have a proud about it as an Indian, but sometime at a certain field we are lagging. We are always thinking very little bit late, and as a result, you can see that European, they started implemented in 1994, but we started realize that effect very late. in 2000, and we are implemented straight away as a Euro 1, and it is applied to the entire nation. Now here, then Bharat, you might be aware about the Bharat BS2, BS3, BS4, the BS6, and then we have used the reference was as a European, whatever the standards they are given, the limits of the each particular emission level, that limits we are using the same, but the implemented at very late, and we have skipped the Euro 5 or a Bharat stage 5. We have skipped. We are the first, only the country in the world who skipped the Bharat 5 stage, and we have straight away go to the Euro 6. Now, this figure will give you comparatively status of Euros and Bharat stage. So, as I discussed earlier, that we have straight away used in 2005 that Bharat BS2, and when we are using the BS2, that time European countries they are implemented the 4 Euro 4, and then till 2015 they were using the Euro 6 standard, but during 2015 latter part of 2017, I can say we were at the Bharat 4 stage only. Now here, just take an example here from Bharat, Euro 4 to Euro 6. They took a 10 years, 9 months. Whereas Bharat 4, Bharat 4 we implemented in 17, and immediately April 2020 we implement the Bharat 6. So before Bharat 4 to Bharat 6, we have implemented in a 3 years. So what is the impact of that? What is the impact of that? That we'll see in a later slides. Now here, these are the emissions level. I will not discuss further that one, because here you can only just see that one grams per kilometer, 14.3. It's reduced to the, now you can see almost reduced and very close to zero now. But here there are very further chances to reduce the emission levels further. So these are the emission of figure for the diesel engine. If you compare the Bharat 4 and the Bharat 6, you can see that for a diesel engine, NOx is reduced by 68%, and particulate matter is reduced by 82%. And gasoline, if we talked about, it reduces to 20% CO, carbon monoxide, and hydrocarbons by 8.5%. So drastic reduction in the emission level is there. So what are the techniques? What are the techniques suggested for implementing the B6? Because B6 we have BS6 we are implemented in April 2020. So here major thrust is given on the fuel category. In case of the Bharat 6, more thrust or more change is given for a fuel. So we are expecting that very clean fuel to be supplied and used in a BS6 engine, and that is termed as a BS6 fuel. Then if we use a BS6 vehicle using a BS4 fuel, will not adhere to the BS6 norms, because we required a proper distribution system to supply BS6 grade petrol as well as the diesel. Then if you compare about the BS4 fuel and BS6 fuel, you can see the 5 times fewer sulfur traces. Sulfur content is a very less in case of the BS6 fuel, and NOx level will brought down, increasing of 70% of the diesel engine and 25% for the petrol engine. And so what kind of technology suggested? The technology suggested what? Real driving emissions. So here the emissions level will be measured on during the driving. At present, the vehicle at one place, and we are giving a different loadings, and then we are testing. So here, while driving itself, So we need to test the emission level in case of the BS6. And what kind of technology they are using? So here diesel particulate filter and selective catalytic reduction, that is suggested, that is make mandatory use in all kind of the CI engine. That is a diesel particulate filter and selective catalytic reduction, that we'll discuss in next slide. So obviously, when we are implementing, when this emissions level is from BS4 to BS6, obviously due to the high end or modern engine, uh, that will be impacted to the customer. So drivability will be going to reduce, due to which heavy exhaust system. So here, due to the complicated and a very heavy system, drive performance of the vehicle may go down. Then noise and vibration harnessing. Obviously, with increased fuel pressure and fuel injector in with a fewer lesser emission, but but it will may result into what, noise and vibration harnessing. Then fuel economy is going down due to the high exhaust pressure drop after treatment. There is, due to the pressure drop, there may be a lesser fuel economy. And to get the clean fuel, I need to pay more. To have a modern engine, I need to pay more. Obviously, the cost is going to increase. So there is a large impact on the customer side. Now here, there are a different emission control techniques are available. Here, if you see the first part is a fuel lubrication and the uh, side. So I can use appropriate fuel and clean fuel, and I can use appropriate lubrication system, which will enhance my, which will reduce my emission level. So at the same time, I should have a good engine with and with a proper control over the combustion, which may lead to the reduction in the emission level. So obviously, it will be associated with the sensor and the control unit. Then different emission technologies I can use. uh, Catalyst, I can use filter, are the part of the complete system, where all the element must work together to achieve the greatest possible reduction in the emission. Then, if we talked about the modern engine, you can see that you can just compare the figure which I have shown, the first engine and this recent modern engine. You can find out the large difference. So here, the modern engine will have the innovations in the turbocharger. We may have the innovation fuel system and the exhaust gas recirculation module. We may use a friction reduction technology and new generation engines. So here, this modern engine should have all these kind of the subsystem to give the better performance. Now here, if we talked about the different technology overview, that there are the two side which I can classify. One is what the engine level challenges, level challenges at the engine side, and the other at the exhaust level. So now here I can have different kind of the technologies I can use, and that is electronic control unit with the proper intake throttling process. Then modern injectors, which will give me the fine diesel particle as well as at a high pressure. I should have a proper turbocharger. Then electronic system with exhaust gas recirculation. Then I should have a pump. So these are at the engine side, and at the exhaust side, I may have different sensor which will to be placed at the exhaust system, and which will give the input to the control unit. And based on that control unit, I need to have the control over the emission. So different sensors, I may have the NOx sensor, lambda sensor, temperature sensor, differential pressure sensor. I can use with along with the control module, and I can work on a exhaust level or emission level reduction. So technology, I can, one is at the engine side, where the more thrust is given on a combustion, and second side mode is given to reduction in the emissions. Now, here on this slide, I will now talk about what are the different technologies people use. So first, as I say, in earlier case in SI engine, we were using the carburetor. Now carburetor is replaced by multi-point fuel injection system, and there are a certain drawbacks. To overcome the drawbacks, the multi-point fuel injection system is used. Now let's take an example. This is a inlet manifold through which air is entering inside the manifold, and let's say this multi-cylinder engine is there, and these are the inlet walls. These are the inlet walls of that engine, and over that walls you can see the fuel line is there, which is connected to the different injectors. So different injectors are there. Let's say if I have a 3-cylinder or a 4-cylinder, if I have a 4-cylinder, 4 injector will be there, and similarly I will have a 4 inlet wall and 4 exhaust wall or exhaust port will be there. Now, so that is mounted exactly on the top of the wall, and it is injecting the fuel. Now let's take an example. The air is coming inside the manifold, and inlet wall is open, and when the inlet wall open, that time this injector, which is close to the second wall, injecting the fuel. Now here whatever the air is coming, it will get mixed here and enter into the combustion. So what are the my advantages here? More uniform air fuel mixture. It will because major problem with the carburetor was the cold starting. That is also eliminated, because here I am getting the more uniform mixtures, which is and during the no load conditions I may get a more fuel, because I require a rich mixture to start the engine, and that requirement can be fulfilled by multi-point fuel injection system, and it will have the immediate response, then accurate supply of air and fuel system. And as these are mixed properly, so proper, as due to the proper mixing, the combustion will be appropriate, and that will reduce the vibration, and it will have the better fuel economy. So these are the few advantages of the multi-point fuel injection system, which eliminate the carburetor from the SI engine, which is having the multiple problems. Now, on the that emission side, if you talked about a diesel particulate filter, so here the filter is of fine mesh filter. It is having the multiple function required to do. It will require to reduce the NOx. It will require to reduce the particulate of filter, particulates of matter (PM). Then here during the process, this filter is the exhaust gas, when it is moving through the porous material, when it is material, the soot get accumulated and makes the filter full. You can see here this filter is entire soot is got accumulated, and it is full, and then I can give the burning to that one, and then I can use that filter to clean. So that is called as it is called as a regeneration. So I can use the filter again by providing the regeneration. So here the diagram, you can say the coated diesel particulate filter. So here how I can design a more appropriate filter for a diesel engine, which will fulfill my BS6 norm. That is really the challenging part. Then lean NOx trap, LNT NOx. So here again some BaNO3 material is stored, NOx is stored in the form, and then it is converted into the that nitrogen, that is N2, and you can see the cycle time is only the 1% for the reducing the NOx. Here it is again the regenerated types, and it is a simple and a less expensive compared to the earlier one, and used in a low power density vehicle. That is a LNT NOx type of the filter. Then recent that B6 used a selective catalytic reduction, where we are researchers suggesting uh, that urea can be injected in the exhaust system. First one is what you can say, that the engine, the exhaust go to the tailpipe where the all the emissions is there at higher level, and then oxidization catalyst is there which is reducing further. But for the reducing further the oxides of nitrogen, the urea is injected inside the tailpipe, and that flow of that one is controlled by the electronic control unit, and I will get the I can fulfill the norms given by the B6. Here the same diagram, same function, but the different way it is shown in this figure. So here selective catalytic reduction technique more appropriately I can use to fulfill the BS6 norms. But here there are what I need to have the proper electronic control unit. I need to have a proper sensor. Let's say, take an example here. Let's say this is a tailpipe. I can sense the temperature, right? If I'm sensing the larger temperature, then I can give that based on the my design. I can give the actuation to the my um, AdBlue tank where the urea and other chemical is stored, which is required to spray or which is required to inject in case in the exhaust tailpipe, and which will be react, and SCR catalytic will reduce the NOx level and fulfill. And at the end, again, I will have the NOx sensor. At the end, if I'm again observing the NOx is little bit higher than the requirement, then again I can increase the quantity of urea, and further I can reduce the NOx level. So I need to have a closed loop system where all the sensor is integrated with the electronic control unit and actively work to reduce the emission and to fulfill the Bharat 6 norms. So that are the now challenges, and that is now the upcoming field. How closely I can monitor the emission level, and how I can reduce, how I can select the appropriate catalyst. That are the really challenging part. Now here, though we said initially the 5 to 10% there is a loss in a friction part, which are the reciprocating. So here you can say the different part: engine block, then bearing kit, crankshafts, then the piston ring, chain system. So different parts are there which are associated with the friction, and which is going, that energy of the whatever is produced by the engine is going as a friction loss. So researchers is going on, so I can provide some sort of the plating, some sort of the treatment over the surface of this part to reduce the friction, and I can get the more appropriate efficiency. So this is also the though there is a less scope of performance enhancement, but still the people are working in this area to enhance the efficiency. Then engine management system and a control system. As I said earlier, so here the I need to have the actuator, that injector, AdBlue dosing, then turbocharger, and then it is to be connected to the that electronic control unit, and I should have a sensor, and which is having the control over the engine block after treatment. Then I have diagnostics and the vehicle networking. Nowadays the vehicle will have the vehicle networking through which I will get the signal related to the traffic surrounded to my vehicle or around my, when I'm moving from the particular locations. Apart from that, I will have the roadside assisted assistance also possible. So onboard diagnostics. So different things are possible if I use the engine management system, and I will have the more appropriate control on the entire systems. Now, now there are the techniques of supercharger and turbocharger people have used widely in the 80s and 90s. basic difference in a turbocharger and a supercharger, as a mechanical people they know. And here you can see that in case of the supercharger, air in, and it may be have rotary or and blow type of the supercharger, which is compressing the inlet air, and compressed air is supplied to the engine, and that taking the power from the engine itself. Whereas in case of the turbocharger, exhaust gas is given supplied to the turbocharger, and and turbine, one side turbine is there which is generating the power, and the power is given to the other side which is compressing the air, and that compressed air is given to the air cooler which cooled it at appropriate level and then supplied to the engine. So that is a turbocharger. So each system is again having the some advantages and limitations. Here I'm not discussing the advantages and limitations of a turbocharging, but here obviously the higher power outputs in case of the supercharger, and it will reduce the smoke from the exhaust gases. Then this is a layout of the uh, turbocharger. As I said, on one side there is exhaust gases which drive the turbine, pass over the turbine blade, generate the energy, and that is given to compress the air, and compress air pass to this. Again, it will have. But if I am using this technology, so whether it is a turbocharging or a supercharging, this technology, if I'm using with appropriate limits, then it can be advantageous. But there may be a certain limitations, because we may require a better cooling system, expensive and complicated design, and there may be a wear and tear at a faster rate for case of the turbocharging. So I need to analyze when I'm using the this kind of the technologies in the existing engine. I need to analyze its added advantages and added disadvantages by using the system. Now, in case of the turbocharger, there are the wide scope for the research. I can go for what integrated with. I can use integrated turbocharger system with exhaust manifold. I may use a variable geometry turbocharger or a turbine bypass valve. So here at appropriate time, the turbine valve should open and close. So if I'm using the integrated system, this can be have the advantages. So this is also the again upcoming area where the people can work more appropriately and get a very innovative type of the turbocharger. Then using the exhaust gas recirculation system. So whatever the exhaust is coming out of the engine, that, as I said, I can pass over a turbocharger and get the power. So here it's a combine the exhaust gas recirculation with a turbocharger. So some amount of the charge, some, this is a EGR valve, exhaust gas recirculation valve. Some exhaust is going over the turbine blade, and some charge is going to the EGR cooler, where the exhaust gas is getting cooled and supplied to the EGR. And then EGR throttle is there as per the requirement. I can check the position, and based on that it is given to the engine inlet manifold. So 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 what is the added advantage? If the exhaust is having the unburned hydrocarbon in the your tailpipe, that is again giving the chance to burn in case of the uh, further addition into the diesel engine. So again, it's a have the control over the air pollution, reduce and NOx level, complete combustion, uh, fuel consumption improves, increase the efficiency of the engine, and obtain the high power. What are the disadvantages? High cost to the engine, complicated design of the engine, and as I said, it's cooling is required, so more cooling, and size of the system is becoming the larger. So I need to have the optimum design which will be work appropriately. Then here these these two diagrams showing you the turbocharge with a EGR system. You can see here this is a turbocharger with a EGR valve. So uh, valve opening and closing if I am able to manage with the electronic control system, I can have the good control over the turbocharger, good control over the exhaust gas recirculation system, and I can enhance the system, and I can able to withstand my Bharat's 6 stage. So this is a exhaust gas recirculation hot pipe. You can see here. So then coming to that SCCI, that is homogeneous charge CI engine, where combustion is not taking place by using the spark. It is the fuel is going getting to be injected. It is getting mixed into the fuel, and the combustion is not by the flame. It is by the different parts. The auto ignition, due to the auto ignition, the combustion is taking place. So here the no flame combustion due to the compression heating. Again, it is increasing the fuel efficiency over the standard stoichiometric SI engine and reducing the NOx emission. This is about the HCCI. Sorry, I think you had not seen that HCCI. So this is a
It's visible.
this is a SCCI I was discussing that the fuel and air is during the manifold itself, it is mixing together. But there are certain challenges. If I'm able to control these things with the electronic control system, and I proper architectures and things are there for the control system, then I can have proper homogeneous charge CI engine. I will take 5 minutes more. 5 minutes I required. Aqleem sir, is it okay?
Yes, sir. Yes, sir.
Coming to the fuel side, biofuel side, if you see, there are again the different challenges. You can see that one that I can. Each system is having the pros and cons. So here I will just go for the what are the challenges with the biofuel. First one is technology, then policy, and feedstock. If you talk about the technology for a biofuels, I may require a pre-treatment. I may require a certain kind of the technology for the production, and which will enhance the cost of the system. Then, unless and until I'm not using the government is not deciding the appropriate policy to introduce the certain sort of the fuel, so there are limitations. So here I should have appropriate land to inculcate or to develop to produce the biodiesel seeds or particular crops which is giving me the diesel. So there are multiple fuels I can use for my engine. So we know that fossil fuel having the scarcity to vanish after a few years. So that is the crude oil, natural gas, and the coal. And regenerative type biomass and other resources I can use as the water, solar, and wind, and I can have the electrolysis process and to produce the hydrogen and vegetable oil for the biodiesel. So I can use an engine with a engine with alternative fuel, but my engine should be compatible to have appropriate combustion. That are the challenging tasks. I will not cover this hydrogen cell. Yesterday's uh, speaker already covered. Then, what are the key strategies for the development of the electric vehicle? Higher carbon emissions. So here, as we are having the lots of vehicle on the roads, India having the major, we are thinking to reduce the emission level. And if I use, let's say, not fully electric or hybrid vehicle, you already seen these graphs in yesterday's presentation. So here, 37% reductions if I use a hybrid or a electric vehicle, then it will be reduced. And if you measure India, as we are importing the fuel, petrol as well as diesel from the outside, so we can save 64% on a fuel which you are spending in terms of the taxes and other part. So here 64% reduction in the cost side. So there are the challenges with the system, but here if the government have the appropriate policy, people can use more appropriately. Now here most of the company already started producing the or starting developing the electric vehicle. Then we have different Ola, Uber, and different transportation companies which are providing assistance to the passengers. So here they are also started purchasing electric vehicles or a hybrid vehicle required to carry out. Then we have a major challenge with the charging system. Yesterday's speaker already discussing, so I will not discuss so much on this one. But if you see at the Indian side, if you compare the China and the other part, United States and the India, you can see that India is given in the black. Here from 2015 to let's say 2040, if I grow whatever the way in which right now the government rules and regulations and customer mindset, I may grow with little bit lesser space compared to the China and the United States. What are the takeaway point from this thing? Here, as a customer side, we should have given the lots of benefit to the customer. Second, the what are the expectation from the customer side? High power requirement, then the charging facility. If I'm able to provide that thing, then definitely electric vehicle will be possible. But it is not at the one go. I can say that in a one night or a one year that your conventional engine will be absolute from our life. It is not possible. So again, I may say that one again next 20, 30 years, though we are saying that electric vehicle is upcoming, so there are the many again the challenges are there, many research areas are there where as a mechanical engineer, where as an electrical engineer we can work together and I can produce the good hybrid vehicle which will have the combination of my conventional engine and electric engine. uh, with this, I would like to stop here. I will take a few questions if if anyone is interested.
Yes, I'll just check the question, sir. Uh, what will happen to engine if BS4 fuel is used for BS6 engine?
Uh,
I am having a BS vehicle, but I am using BS4 fuel.
because that is will not give the appropriate because BS4 fuel is having the little bit impurities. Sulfur content, majorly sulfur content is more, and obviously it will not fulfill the BS6 norms because I am using the BS6 engine. I am as a customer, we are paying to buy the BS6 engine, but if I am not getting the proper BS6 fuel, it is wastage of time, wastage of money again because I will not able to fulfill the norms. I hope I have answered this question.
Any other participant, if anyone wants to ask question, you can press the raise hand button so that I can unmute you. Okay, attendee number 164, 174, sorry. You can unmute yourself, number 174.
Myself Puneet. Sir, hello. Can you hear me, sir?
Yes, audible.
Yes, sir. Sir, is this BS what we are using currently now, BS6 engine?
Yes.
Is this regarding engine or is this regarding fuel what we are using?
Here,
I think.
BS
Yes, sir. Yeah.
BS4, if you, because in India we have skipped the BS Euro 5 norms. Straight away we have
Yeah.
got BS4 to BS6. So here
Yes.
major major thrust is given for the fuel. So
Okay.
fuel should be clean. It should be sulfur free.
Okay.
And
Okay. Okay.
they have said clearly that each this one engine, diesel engine, should have
Mm.
uh, system like the uh, elective catalytic
Mm.
reduction systems
Reduction.
and diesel particulate filter. Diesel particulate
Okay.
filter. This is
Yeah. Yeah.
due to which the again the cost of the vehicle is going to increase.
Increase. Okay, sir. Okay. Yeah. Yeah. So as well as engine as well as fuel, both have been revised, right? In basics.
Yeah. Yeah.
Yeah. Yeah. Yeah. Okay, sir. Thank you. Thank you so much, sir.
Uh, Sorry that at the last part I have rushed through because I found that 20 slides were remaining and I have at time I have only 15 minutes, so I have moved little bit faster.
Participant number 052 has raised hand. You can unmute yourself. Participant number 052. Hello. Yeah, ID attend.
Sir, hello.
Yes,
Yes, you're
yes,
on.
Hello, am I audible?
Yes.
What
yes,
will
sir.
the status of the retrofits in years to come? We are talking about the EVs and all that, but presently we got large number of cars and all that. So it is not going to be waste, what I think. So what will the status of the retrofits in coming future? Is the research going on retrofits in
No,
various companies?
again, see here. What happened now? Government has given the norms. Yeah, uh, while company need to follow the BS6 norms. But at the same time, and again, at the technology side, if you see, drastically it is not possible. It is not a that things which we can complete within a 1 year. Many years has to go. Or maybe 10 to 20 years may required. So here again, government policies are very much important. How retrofittings permissions they are giving for fulfilling the BS. What happened to the existing vehicle? They are not given the clear cut guideline till now. They have just
It is going to be very slow process.
yeah very slow. So that's why people are saying
Slow
many people
process.
are,
It's a slow process. Slow
yeah
process.
many yeah many people are saying that one conventional engine no. Still I am saying that one engine there for next 30 to 40 years also segment. So we should not stop our
Yes. People
in
will be
this age.
slowly. People will be slowly adopting because in the
Yes, yes,
Indian culture, what I feel is that people will be slowly adopting the things. They
adopting,
want to use the same car, same things in a number of years to come. So chances of retrofits may be higher. What I feel, I
obviously.
I was asking your opinion. Huh? Yes.
Thank you.
Thank you, sir. Thank you. Thank you.
Okay, thank you. Now coming to the chat box. BS6 fuel availability. When will it be available across nation?
See, actually, six norms implemented in April 2020. That was during the lockdown period, right? And there are a few now companies. They are now started supplying that, but that is again the major uh, metro cities, not for entirely. So now slowly that distribution side channels will improve and hope very soon we'll get that kind of the fuel.
Okay. The next one is vehicle. These standards are.
Voice is breaking.
Hello.
Yeah, tell me.
Even in electric vehicle, these standards are there. That is one of the questions.
See, in electric vehicle, if you see that there is no combustion. So direct emission is not there, but indirect emission is there, which is what we are using the electricity, and electricity is produced in some sort of the power plant. So in the power plant, there will be the emissions. So obviously the way using the one side, but there will be, please mute yourself. Please mute yourself. Please mute yourself. Thank you. If you see that, if we use the electric vehicle, definitely there will be a zero emission. But at the same time, the electricity we are using, which is produced in a thermal power plant, their emission level is going to increase. And if we use a hybrid vehicle, obviously we need to follow these norms because emission is there. I hope I have answered your question.
Sir, two very quick questions because we are running out of time. One question is, we have moved from two-stroke to four-stroke engine. So are there any newer engine types under development?
Yes, people are working for a 6-stroke engine. People are working on an 8-stroke engine. Multiple things are going on. But as I said, we have spent more than 100 years in this engine development, but marginally we improved in the efficiency.
Correct. Next one is, what benefit hybrid electric vehicle gives over conventional vehicles? This is the last question.
Obviously, the hybrid vehicle, yesterday also Mr. Nibande has clearly mentioned that if we use a hybrid vehicle, and in case of that, if I want to travel in a city, I can use an electric vehicle, and if I want to go on a highway, I can use a conventional. So where I can get a mixed kind of the things, and I can improve my thermal efficiency up to 50%, from 25 to 50%. Because I am using the conventional fuel as well as the electric one.
Okay. Okay. Thank you, sir. Thank you, everyone.
Yeah, thank you. Thank you all of you for your patience listening. And sorry that I have rushed to last a few slides.
Yeah. Just a small announcement for everyone that the feedback link has been posted on WhatsApp chat. So kindly give your feedback. And the next session will be at 12 o'clock. Next session will be at 12 o'clock, and calendar entry would be made just within 2 minutes. So just ensure that everybody enters in the meeting of day 2, session 2. Okay. Thank you all very much. We'll see you at 12 o'clock. Thank you.